I am Ann Rose.
And I'm Ajit Vanniamparampil.
We are from the Human-Computer Interaction Lab here at the University of Maryland. We are currently working on a project for the Maryland Department of Juvenile Services. DJS is responsible for handling juvenile case referrals for the entire state of Maryland. In this video, we will demonstrate how we are using IVEE, the Information Visualization and Exploration Environment, to explore a data set of case referrals.
IVEE was developed by Christopher Ahlberg and Erik Wistrand of Chalmers University, Sweden. IVEE is partially based on our earlier research on dynamic queries and information visualization. Christopher was involved in some of this research. Our early prototypes included a home finder, a health statistics browser, and a film finder. Those prototypes had to be custom made, while IVEE is a generic tool that allows us to build dynamic query applications with minimal effort. Let's look at an example of the film finder built using IVEE. IVEE automatically provides query controls for each of the attributes: a toggle box for the film subject, a range slider for the length of the film, and alpha sliders for the actors, actresses, and directors. Each dot represents a film and is plotted on a star field display. The year the film was made is plotted on the x-axis and its popularity on the y-axis. We can change these attributes using the X and Y menus. The color of each dot indicates the subject of the film. For example, red dots are action films. Now let's use IVEE to explore a dataset of environmental data in Sweden. The dots represent measurements of heavy metals and are plotted on a map of Sweden. This dataset can be used to find pollution trends. For example, using the chrome level slider, we can see that the level of chrome is higher along the rivers where more factories are located.
For our DJS project, we have been using IVEE to explore approximately 5,000 case referrals received during the month of July 1994.
Each dot represents a case. Here we chose to plot the youth's age on the x-axis and the number of days to make an intake decision on the y-axis, where an intake decision is the department's recommendation for how the case should be handled. We could also imagine plotting the received date or the case severity on the axes. IVEE currently supports integer and string data types. For demonstration purposes, we have multiplied the age by 10. The color indicates the race of the youth. IVEE allows us to change the visualization settings. We can imagine coloring by sex or by area of jurisdiction. We can also choose an attribute for labeling. IVEE is useful for identifying trends and outliers. Right away, we can see that there is a problem with age. To explore further, we can click on one of these cases. Here we see that the problem is that the date of birth was not entered. Now let's zoom in on the ages 10 to 20. Ideally, intake decisions are made within 25 days of the received date. However, several cases required more than 25 days. Let's use the county alpha slider to compare the workloads of the different counties. When there are only a few dots on the screen, the labels automatically appear. Here, the cases are labeled by alleged offense. We were intrigued by these two short lines. We know that these cases are all being processed by Area 2, since they are all yellow. If we filter first by area, and then by alleged offense, we notice that these cases are all narcotics possession cases. Further exploration shows that these cases were received on the same date, which leads us to believe that this might be a drug bust.
In just a few minutes, IVEE allowed us to explore 3 different trends associated with the age of the youth, the workload of the counties, and a particular offense pattern. Future plans include using a map of Maryland to explore regional trends and developing algorithms to handle large data sets. Thank you.